5.6, division of polynomials. We've seen multiplication, we've seen addition and subtraction. Again, with division, really, we're just going to be changing these into, well, no, we're not going to be. This is straight division on these, okay? So we should be looking at like one fraction at a time. And this is, when it says division, another way to say this would be long division. And since we love long division, we will probably love this section. Dividing polynomials, long division and short division. Dividing a polynomial by monomial, divide each term with polynomial. Okay, so this one's just saying, look, if you have an individual fraction, you can split it up into each part. Just remember that whatever the denominator is can't be 0. So if it asks for a domain, we'll have to keep that in mind, but I don't think it does on these ones. This is good if it's, I would say if it's a monomial down here, like it's a one individual part of the expression by itself, like we will see in the next problem. But once these are, once the denominator is some kind of binomial or trinomial, which we shouldn't see. Binomials we will see though. We could, but for this type, we're just looking at some kind of monomial in the denominator, like this one, okay? So what I'm saying here is that you could, if you wanted to, you could take this and you could split it up into 3 separate terms, because that's what having a common denominator does, right? Like we've seen in the past, we forced denominators to be the same, and then we combined it into one individual fraction. This one's one individual fraction that now we are going to separate into 3 separate fractions. Now it's always addition between because these ones are showing addition, so I guess not always, but in this case it's addition. So then what do I got? I got 15x to the power of 9 over 5x to the power of 7 plus 40x to the power of 8. But again, it's divided by the same denominator, 5x to the power of 7. And then I got 5x to the power of 7 over 5x to the power of 7. So right here, we look and we see, just focus on one of these at a time. So kind of like what I've done before, I'm just going to ignore all this garbage for now. I'll come back to it. I'm just going to ignore it for now. And I'm going to work downwards, okay? So from this fraction, I can see, I'm going to start with, I like to start with the letters. I'll do letters on this one. I'll do numbers on the next one. So I'm looking at the x to the power of 9 over x to the power of 7, okay? Now, if I divide those two, you could just do 9 minus 7 in the exponents, but I know that these 7 are going to become phantom 1s with 7 of those, and I would just be left with x to the power of 2. And this is in the numerator. Why is that? Because I have more x's in the numerator. Now, of course, you could say, well, yeah, just apply those exponent rules, do 9 minus 7, you get x to the power of 2. It's the same idea, as long as you understand that this x to the power of 2 goes in the numerator. If it was negative, it would go in the denominator. We shouldn't see any negatives right now. Then I'm going to do the numbers part of that, so that would be 15 over 5. It's really 15 divided by 5, which is just 3. So I end up with 3 times x squared. That means also, right here, I don't really need the divide the fraction line, okay? Now, could we need it for the other ones? We could, but I don't need it for that one. Okay, so again, now let's move to the next one. I said I'd do the numbers first on this one, okay? So this one is showing I got 40 divided by 5. Again, that's a straight calculation. That's just 8. It's positive 8, by the way, so I'm going to show it as plus 8. And then I will work with the variables here, x to the power of 8 over x to the power of 7, which is really x to the power of 8 minus 7, which is x to the power of 1, which I'm going to show just as x. But if you put if you want to put that phantom 1 there, that's fine. I'm just not going to show it. And now the final term here, I'm going to do this a long way, then I'll explain the shortcut, which doesn't always happen, by the way. So last one I did the numbers, I'll do the letters first this time. So I'm going to look at x to the power of 7 over x to the power of 7. This would be x to the power of 7 minus 7, which is x to the power of 0, and anything to the power of 0 is just 1. So I'm going to put the 1 there, and I'm putting it there specifically because with the numbers, you got 5 divided by 5, which is just 1. I don't need 2 1s there. I don't want to put it like that because then it looks like 11. even if you put the multiplication between those, by the way. But it's positive 1, and I kind of expected some fractions there, but we didn't have any, and that's okay. That's just our final expression right there. So yeah, in this unit, we're used to factoring this. This one can't be factored, so it is done. Video, so thank you. This, yeah, you could have said I'm going to factor out some well, it looks like 7x's, right? So x to the power of 7 and 5. Yes, thank you. That would have shown you that you could have just kind of canceled those out. Which one's easier? I don't know. This is the way that I'm used to doing it because I'm a math nerd. But I'm glad you saw that. You could have factored out a 5x to the power of 7 here, and that would have left you with this. So now we're going to start seeing some where the denominator is a binomial. Fill in any empty degrees with 0x to the power, to some degree, okay, whatever the degree is. Talk more about this, but so I'll demonstrate this first part. It says fill in any empty degrees with 0 times x to whatever the degree is. So if you look at a difference of squares, right? So if you had like 4x to the power of 2 minus 9, like this, it's missing a degree, right? You have a degree 2, you have a degree 1, which isn't shown, and then you got this 0 degree term. What it's saying here is that you could, if you wanted to, you could rewrite it with that degree in there. So then you would have 4x squared plus, again, you'd show it as 0, its degree is 1. Again, this is now in descending order, and then you'd have the minus 9 right there. Now, is that important? I mean, if you're gonna do this by factor by grouping, that would work. But we don't really need to show that once we figured out we had the difference of squares, which is more like an algorithm. But now, for some of these division type problems, we may need something like this if we see that one of those terms is missing. So you got to be careful with that, okay? Now the dividend, that's the numerator, it must be in descending order. So this one was in descending order, was just missing this middle term. Well, what this is saying here is that you don't want to see lower degree terms and then higher degree terms. So you don't want to see something like x squared or 3x squared plus 4x to the power of 5 minus 8. This is out of order, descending order, right? So you'd have to say, well, I'm going to rearrange this in descending order, so it'd be 4x to the power of 5 plus, again, you could show the missing terms here, 0x to the power of 4 plus 0x to the power of 3 plus 3x squared plus 0x, and then minus 8. Sorry, I got kind of cluttered there at the end. But you don't necessarily need those, you know, so you could just say, well, that's descending order too. That's fine. But again, we're probably going to need some of those 0x terms if we see any that are missing. So if the divisor is a binomial, ignore the second term. Figure out how many dividends will go into the first term and multiply the binomial by that value. What we're trying to do here is to get the, we're trying to see how many of something goes into something else. That's what division is. But we don't really, in the binomial, we don't care about the second term. Okay, so like a binomial we've seen before, x minus 2, right? If I'm looking to see how many of these go into x squared, I really don't care about the minus 2. I just care about the x. So the first term, that's all you're concerned about. We do work with the second term, but the first term is really all that we're trying to get, essentially to match with whatever this term is, right? So like this one, you'd say, well, how many x's go into x squared? An individual x would, okay? That doesn't have to make sense right now. We're going to see this. But this is how you do long division with these polynomials. Long division, though, right? If you saw something like 2 over 3, long division sets up as 2 divided by 3. Okay, the numerator goes into the division sign, inside the, I'd say inside, and then the denominator's on the outside. Okay, so if you saw something like x over 4, again, long division would show x divided by 4, right? So these fractions, again, the denominator is on the outside with this division. How many of these go into this thing? Example will kind of clarify what we're talking about. But again, it's important to put this into long division format. So this one, let's go ahead and set this up. I'm gonna see if I can do this decently. That's not my worst, so I'm gonna keep it. So my numerator goes inside my long division symbol, 9x to the power of 3 plus 57x to the power of 2. Oh, by the way, this one's already set up in descending order for us. Thank you for that. Minus 39x plus 30. And this is being divided by x plus 7. Okay? Now, the other thing with long division is that you remember whenever you find your quotient, this is where my quotient goes. But when we find a value that goes into the quotient, remember you kind of multiply it back, but you have to multiply by both of these terms now, okay? Now, that's the only time I'm really concerned about the plus 7. Okay, so again, we say, well, how many x's will go into x cubed? Well, two of those will go into x cubed, so I'm going to make this x squared, right? So, again, putting this back into the division, x squared times x. Hopefully we kind of remember that. Again, x squared times x gives me then the x cubed, but we used up those x cubes, right? Now the problem here is if I subtract this, I would still be left with 8x cubes, right? Because you'd have 9x cubes minus 1x cubes, that's 8x cubes. We don't want that 8x cubed there. What we'd like to do is zero this 9x cubed out, right? So that's one way to get rid of the x cubed, but I need 9 of them. So I go back up here to the quotient. I say I'm gonna need 9 of these x squareds multiplied by the x to get rid of the 9x cubed. So now I got 9x squared times x. Now it's 9x cubed. And again, why is it subtraction? Because that's what division is. It's saying that we've used up, by multiplying these, we've used up the 9x cubed. Okay, so that does zero that out, all right? But like I said, you can't just multiply by the x. You got to multiply by both of these terms. So then I'd have to take, here I've got, from this, I don't know where to show it, I now have to take my 9x squared and multiply it by 7. Okay, now that's going to give me 63x squared. So I end up, by multiplying by 9x squared with 7, I'm ending up with an x squared term, and I can see my x squared term here. Okay, so I don't want to pair it with my x's or my constants, but I've used up, so I'm subtracting 63 of my x squareds. Okay, and that again comes from the 9x squared. I'm multiplying here. So what's left over? I'd have negative 6x squareds, but then I have everything else that I drop right here. It's kind of like what we would see with long division of place values. So I got minus 39x plus 30. Okay, so this 9x squared, again, that's part of my quotient. And now that I've done that, I'm not focused on this original part of the expression, okay? I'm focused on this one now. So I go in here and I say my x's, right? Okay, so I need to make it an x squared. So that means I would have to multiply an x by an x, okay? Because x times x, that's going to give me this x squared. But see how it's not just 6x squared, it's even a negative 6x squared. So I'm going to have to, I'm going to need to be able to add here. And so it's kind of like we're taking away the negatives. That means I'm going to have to make this a minus sign. And I'm going to need 6 of them, okay? So this is now negative 6x times x, which would be 6x squareds. But again, since it's negative, I'm now adding those in, taking away those negatives. Okay, so again, what does this do for me? It zeroes this out. But again, I now need to multiply my negative 6x by the 7, which would be a negative. So I'm going to have to add that as 42 x's. So again, we focus on the first term in the binomial, but you need to do whatever you have in your quotient. You got to multiply both terms in your binomial there. Okay.
Well, what did a negative?
Another way to say this, right? So remember up here I did 9x squared times the x, and then I was subtracting for both because it was when I multiply these I end up with positives, so I take them away. It's kind of like, well, if this number is positive, then I'm multiplying by a positive. This one was negative, so I need to make this a negative here. That's another way to look at it. So as I go through here and I'm going to continue evaluating this. So negative 39x's plus 42x's, that would be 3x's, and then my plus 30 again, that drops. So again, is this next term, is it going to be positive or negative? Well, this is a positive 3x. And so I am expecting my quotient to be, the next term of the quotient to be positive. Okay, because again, it's a positive 3x. This positive times a positive is going to make this a minus. Okay, well, I don't need to multiply by an x because this one has an x. What I then need is three of those x's. So I'm going to make this a 3. Again, 3 times x would be 3x that I've used, so I'm going to have to take those away. All right, and then in addition to that, right, 3 times the 7 there would be 21, but again, we've used those up. Okay, so 3x's minus 3x's, that does zero out. 30 minus 21 is 9. This is my remainder, by the way. So my final answer ends up being the quotient because, and you may be saying, well, what happened to 30? Well, we used up 21 of the 30, but I can't really do anything with this 9 and the x. Okay, you could say, well, you could divide it by x, but we're just going to declare this the remainder. Once you can't work with the x's any longer, because there's pretty much always going to be x's in these now, you're pretty much done, okay? So on this one, we have the quotient, 9x squared minus 6x plus 3. And then we can just say that, yeah, we got the remainder of 9. On the assignment, sometimes it's 2 boxes. They'll say, what's the quotient? This is your quotient. What's the remainder? It's 9. You just fill in the 2 boxes. Sometimes, though, it may say, well, we don't want you to show the remainder as a separate box. Well, if that's the case, then you're going to have to put this in here like this. But then the remainder, right? This is what you got remaining from there. And so we take that and we add it into this. The remainder is, again, it's 9 parts out of the x plus sevenths. So it's just, that's all that remained out of whatever we were dividing by, which in this case was x plus 7. Again, is either one better than the other? I don't know. But they're going to ask for either one sometimes. Sometimes they'll ask for this one, sometimes they'll ask for this one. Both are good.
No factoring a 3 out of that?
No need. Oh. So, you know, I look at this one and I wonder, no, maybe you could factor out a 2 here. So let's go and show some division here. Let's see if I can get the technology to help me on this one, though. Okay, so that's our dividend. Again, that goes into the divide symbol. I'm okay with that. And then the denominator here is on the outside of the division. Now again, you know, we look at this and in this unit, we get so used to factoring, it's like, let's factor out a 4 right here. Again, I just don't know what it does for us. In fact, I don't think it does anything for us. So I'm not going to, okay? What I do notice is that 28, 148, 156, I believe are all multiples of 4, which is convenient, at least. So here, again, I'm looking at the 4x. We'll apply whatever the quotient is here to the 16, but I'm just focusing on the 4x and the 28x to the power of 3. So I like to start with the letters. You can start with the numbers if you'd like. So for this one, you'd say, here I have an x, but I need 3 of the x's. So that means I need 2 more x's. That's x squared. Okay, so the x squared times the x, that will make it an x cubed right here. And again, so now we got to work with the numbers, right? So I got to make the 4 28. How will you make a 4 28? Again, with multiplication, you'd have to multiply 4 by 7. So 7 times the 4, that's going to be 28. That's what we're taking away. And again, it's not complete because now I've got to multiply the 7x squared by the 16. That's going to give me some number of x squared. But there's my calculator. 7 times 16, 112. So we used up, so that's minus 112. Now again, is it, how do we know that there's a positive 7? It's because it was a positive 28 there, okay? So by subtracting, we have now zeroed out our 28x cubes, and then I got 148 minus 112. Yes, I did put that in the calculator because I don't trust myself this early in the morning. But I get 36x squareds from that. Everything else drops, and this gives me a new expression to work with, 156x, and then plus 39. I didn't check this in the beginning. I guess I've kind of got used to it, but this was already in descending order, by the way, so we didn't have to actually rearrange the order. Okay, so I got 4 x's. Again, we'll apply the 16, but the 4 x's and the 36 x's. It's missing an x, from there. So x times x, that would be x squared, but we need 36 of them. And since the 36 is positive, I'm expecting a plus sign there. What do I got to multiply by 4 to get 36? It's old 9er. 9 times 6 is 36, but we're going to take that away. Okay, so that's going to zero that out. Then I got to do 9 times the 16 as well, 9x times 16, which would be 144 x's also have been used. So that zeroes those x squareds out as planned. I got 156 minus 144, I believe that's 12 x's. And then we'll drop positive 39. Now, 39 is not a multiple of 4 or 16, so I am expecting some amount of remainder on this. But first, again, I already have an x with my 4x, so I don't need to multiply by another x here. But what I do need then is I need to multiply 4 by something to get 12. And the 12 is positive, so I'm expecting a positive number here. It's going to be 3. 3 times the 4x's would be 12x's. Again, we've used those up. So then 3 times 16 is 48, but again, those have been used up. So it looks like we've zeroed out the x's as planned. 39 minus 48 is negative 9. Again, well, that's my remainder right there. Remainder of negative 9. I'm going to change that color because it's kind of a different part there. So what is our final answer, our quotient? Well, it was 7x squared. I can usually do better 7 than that. Oh, crap. There it is. 7x squared positive 9x and then positive 3. But then we had a remainder of negative 9. And again, I'll show this both ways again because it may ask for either one. But then you'd add, well, I guess it'd be, you could say plus negative 9, I suppose. That'd be over whatever your divisor was in the beginning, 4x plus 16. Either one of these work. So I know this is only our second problem, but you may have noticed that these, since this was in descending order, our quotient ends up being in descending order. And while this is just an x, we end up just kind of having 1 less x, 1 less x, 1 less x. So this one, we have 2x squared plus 5. Okay, so in the denominator, we now have an x squared, right? Our numerator, oh, that's nice. It's already in descending order, so let's work with that. Again, it's division, so the numerator always goes into the division. And then the denominator, that's on the outside there. Let's make that a little bit bigger, maybe we can. All right, so on this one, so now we're dealing with an x squared, right? So we got an x cubed. You know, I don't really care about the 5. We'll apply the 5 with the quotient, but I don't care in the beginning. So got an x squared. I need to make this an x cubed. That means it's missing an x. Okay, now the other thing too about this is that we got 2 x squareds there. We already got 2 x cubes. So x times 2x squared is already 2x cubed. There we go. Okay, those have been used up, so we're subtracting those out. But then I've got an x times 5, which is, by the way, 5x. Now, here's a common error we see. You're using up those 5x's, and then students will say, negative 4 minus 5 would be negative 9. That's how many x squares I got. No, this is not what you have. This is an error right here, which I've done deliberately to show you a common error. These are x terms. This is an x squared term. You can't combine those. So please don't, okay? Your x terms are one term to the right, so that that 5x that you got that you're going to take away, it has to be combined with that x term. Now that's okay. It's okay that they're not exactly lined up like we've been doing. We did zero out the x cubed, which was really the full purpose of what we just did. But the negative 4x squared, it just drops because you can't combine an x term with an x squared term. But we do have 7x's minus 5x's, which would be positive 2x's. And then the minus 2 right there just drops because we didn't have any other constants from that. Okay, well that hopefully that was helpful, but we're not finished. What I got next is I've got an x squared. There's my x squared. What I got to do is get rid of that negative 4. Since it's a negative 4, I'm expecting subtraction here, but I've got to make the 2 a 4. I've got to multiply something by 2 to get 4. It'd be 2. Okay, so again, 2 times 2x squared would be 4x squared. And since it was minus there, we're going to add that in. Okay. So same thing here. I've got negative 2 times 5. Well, really 2 times 5, which is 10. Again, don't put the 10 with the 2x right there. That's a mistake. Don't put it there. It's a constant, so it has to be shown down here. And again, this was minus, so we're gonna have to add those in. Okay, so what does this give us? Well, again, I can drop my two x's. We did zero out the negative 4x squared, as was part of the plan. And then negative 2 plus 10 there is going to be positive 8. All right? This 2x, there's not enough x's with the x squared. Otherwise, you're going to have to start dividing by x's, and that's garbage. So that's actually my quotient right there. It's just x minus 2, and then our remainder, which is, you know, kind of big right there, but it's okay that it is. Our remainder is just the 2x plus 8. Okay, or again, you could rewrite it as the x minus 2, and then you can add in your remainder, which was 2x plus 8, over whatever your original denominator was. There we go. And this would work too. This one's exactly the same thing, it's just written different. It's f over g of x, which we've seen these functions written like this, right? So all this is telling us then is really to take f of x and divide it by g of x like this. Okay, well that's nice, but what is f of x and what is g of x? Well, it tells me up here f of x is x squared plus 8 plus 21. So I just replace it with its expression. And then g of x is x plus 3. So that's our denominator. And you can see it, I mean, is this a lot of work to get from this to this? No. Is it even a lot of writing? Well, I use the technology. But a lot of this stuff is skipped. Most students would just say, okay, it's f over g of x. They just write it like this. They don't really need all this stuff. But again, if it helps you to see this, then so be it. But now that we have that, we're ready to use some long division, right? So I'm going to take my x squared plus 8 plus 21, and that would go inside of the long division symbol. And then our denominator is always on the outside. Okay, now just so everyone understands, this does read x squared plus 8x plus 21, all divided by x plus 3. It's just written with long division. So here, again, just focusing on my x and then the x squared. Well, that x is missing an x. There's not a coefficient here to really match, so we're just going to keep that as a phantom 1. X times x would be x squared, which we've used. And then we'd have the 3 times x, or x times 3, which would be 3x's. Again, those have been used. So again, the purpose there was to zero out our x squared. And then I've got 8x's minus 3x's, which is 5x's. And then my positive 21 just drops. Now, I've got 5x's and then an x, so I don't really need another x, but I need 5 of them, right? So I'm going to have to take that x and multiply it by 5. The 5 there in red is positive, so I know it's going to be positive 5 there. 5 times x is 5x's that have been used, so subtract those out. 5 times 3 is 15, but again, those have been used, so that's subtraction as well. We zero out our x's, and we're left with a remainder of 21 minus 15, which is positive 6 here. Now, again, how do we know this is a remainder? Because there's no other x's to work with. This x, just like the last one where it was x squared here, but we had x's in the end, there's not enough x's to work with, okay, without dividing by x, which we don't want. I mean, we can show it in the quotient, which is fine with the remainder, like this, right? So x plus 5 is our quotient, but our remainder is 6. Or you could write it as a full expression with x plus 5, and then your remainder is just added to it. Well, the remainder was 6, and it would be 6 over whatever the denominator was in the beginning. So this is how we would want to see the division here. Otherwise, you're going to make this, well, it'd be really ugly at least. But yeah, either one of these, again, it just depends on how it words it in the assignment. Does it want the quotient and the remainder? Does it want the quotient with the remainder? It should specify, though. We've seen remainders. I expect that there will be, but I can't guarantee that all of them will have remainders. Like if this was a minus 21 right there, there just is no remainder, and then the quotient is just your final answer. I don't know that happens very often or ever, but it could.
Changes.
All right, so yeah, this one right here, it's out of order. the numerator is out of order, and we're missing a term. Maybe we'll need it, maybe we won't, okay? So this numerator, now let's go and rewrite it in there, right? So let's take that, the 9x cubed is the leading term. It's the highest degree term there. But the negative 44x squared, yeah, that needs to be next. Okay, but in addition to that, just in case we need it, I am going to apply a plus 0x because we're missing that x term there. And then I'm going to do then we got the constant minus 28. Okay, so this is in descending order. Is it true descending order? Yeah, whether you show the 0x or not, by the way. But the denominator is the x minus 5. Okay, so this is long division, and I'm going to take my numerator, which I've written graciously and pretty, and I'm going to divide it with long division by x minus 5. So divide it by x minus 5 here, okay? So at this point, again, we want to get that quotient with some kind of remainder, but again, I got 9x cubed. I am now missing at least 2 x's, x squared, but we're going to need 9 of those, right? So 9x squared times x would be 9x cubed. That's what we're getting rid of, so I'm subtracting it. But then I've got to multiply it by the negative 5 as well. Now the negative 5, multiplying this by a negative, is going to, even though we're taking those away, since we're multiplying it by a negative, it's going to make that a plus. So 9x squared times negative, well, just really 9x squared times 5 would be 45 of those x squareds. Okay, so that's, oh, that's going to be one individual x squared. That's actually kind of nice. We did zero out the 9x cubes, though. And then everything else drops, right? So we got the plus 0x. Maybe we're going to need that. Maybe we won't. I think we will, but let's find out. And then, again, we're focusing on just this part of the expression, but x squared, I already have an x. That means I'm missing an x. So I'm just going to, since it's positive down there, I'm going to keep this plus. X times x is an x squared. You can say 1x squared if you like. That's what I'm taking away. But then I've got the x times negative 5. So again, that would be plus 5x's right there. So that does zero out the x squareds. And then I've got 0x's plus 5x's, which is 5x's. And then the negative 28 drops. I can actually keep working with this one. Yeah, so on this last part right here, we are missing, we got the 5x, so I'm going to multiply that x by 5, positive 5, because it's a positive 5x down there. 5 times x would be 5x, but I'm going to take those away. And then 5 times 5 is 25, but it's really 5 times negative 5, so I'm going to have to add those in. Now again, the purpose of that is to get rid of the 5x's there. Negative 28 plus 25 gives us a remainder of negative 3. So again, let's go ahead and write that quotient down with the remainder. We got 9x squared plus x plus 5. And then we have a remainder of negative 3. Or, if you wanted to, you could write it as 9x squared plus x plus 5. And then just, again, whether you put addition or subtraction here, I mean, it does make a difference. So you could put minus 3 like this over the denominator, x, yeah, x minus 5, yep.
Let's do the next one.
Yeah, this one's already in descending order, so we don't need to change this one, at least, right? So this one, we're going to take the numerator and divide it. So here's my long division.
Can we do it ourselves?
Yeah, so that's how our long division sets up right here. And this is already in descending order. That's nice. 4x minus 5. Get our quotient, 9/8. All right, so at this point, right, we got to get through this stuff. And so I see I got the x cubed. I'm starting with the x's. I need 2 more x's there from that term then. So that'd be x squared. X squared times x will, in fact, give me the x cubed. But how many of those do I need? I have 4, so I need to double that, right? So I'd have to multiply that by 2. 2 times 4 is 8. But I'm taking those away because those are being used. And now I've got to multiply the 2x squared by the negative 5. Now, in doing that, 2 times 5 would give me 10 of the x squared. But since it's a negative 5, actually, I'm going to change that operation. Instead of subtracting that out, I've got to add it in. Okay, so what does this do? It actually zeroes out the 8x cubed as planned. But now I've got negative 22x squared plus 10x squared, which is going to be negative 12x squared. Everything else just drops, so that's nice. Got a positive 35x. and a negative 27 there. Okay, now that I've got that, I ignore everything up here. Now I'm just looking at this. 4x's, how many times will it go into negative 12x squared? Well, I know I'm going to need an x. And by the way, that's a negative 12, so I'm expecting this to be minus, by the way. And, excuse me, and I would have to triple the 4 to make it a 12. So 3x times 4x would give me 12x squared. But it's a negative 3x, so again, instead of taking that away, I've got to add it in. So again, the purpose of that was the whole purpose of putting the negative 3x here so that we can zero out the negative 12x squared. But now I have to apply it to the negative 5. So negative 3 times negative 5 would be positive 15x's. And again, it was a negative and a negative. Since it comes out as a positive, I'm going to take that away from the 35x's. So that does zero out the negative 12x squared as planned. 35x's minus 15x's would be 20x's. And then, yes, we got the negative 27 that drops. Okay, well, this is good because I've got an x already, so I don't really need to apply an x here. But 4, what do I got to multiply 4 by to get to 20? It'd be 5. And the 20 is positive, so I got that as positive 5. 5 times 4 would be 20. That's how many x's there are being used. So I got to take that out. 5 times 5 is 25, but it was a negative 5, so I'm going to have to add that in. That zeroes out the 20x's. Negative 27 plus 25 is negative 2. That's my remainder. Okay, so again, let's go ahead and write this out as a full quotient. 2x squared minus 3x plus 5 with a remainder of negative 2. Now, again, it just may ask for it in different ways with the quotient and remainder like we saw right there. Whatever it does, though, we definitely need to be able to write it both ways. Okay, so sometimes it'll just say, well, include the remainder in the expression or however that is done. Now, since it's a negative 2, unlike the last one, we could write this as negative 2 over whatever the denominator was, which was 4x minus 5. But like you've seen, you can make that a plus sign right there with the negative 2. Either one works. It really just depends on how you want to write it. But I believe the assignment actually will accept both of those. So again, sometimes it will have this as 2 different boxes. Sometimes it's just one individual box. In that case, it wants it like this. All right, so let's go ahead and make up one of our own and see how fun this is. All right, so we're gonna divide, right? So we'll say we'll divide, and we'll make it some kind of fraction here, which we will use long division. So
Let's make it miserable.
Well, no problem. I thought it already was miserable, but here we are. So let's see if we can get something out there. Now I'll do the denominator let's do an x. No, we don't want any of those.
Let's do logarithm back.
Do you guys want a coefficient?
Graph it.
No, nothing too difficult, but enough
Okay.
where we have those zeros,
Okay.
if you could.
Let's make it a coefficient of 2. 2 is not too bad to work with. Okay. Now, do you want something added or subtracted next? Because we should. What do you want added?
Subtract.
Subtract what?
3.
3. Okay. Now we got to go to the denominator. Let's miss some terms on purpose, though, right? Some of those degrees. What do you want to start with? X to the power of what? 6?
Oh my God.
5?
5.
5. Okay, we'll do it. But do you want a coefficient there? You want a coefficient there?
Yes.
Okay, we'll make it even so that it's not so bad.
4.
4. Okay. Positive or negative?
Positive.
Positive.
Okay, positive. Next one, you want positive or negative?
Positive.
Positive. We'll skip it. We'll make this one an x to the power of 3. How about that? Because it's so fun. Do you want a coefficient?
Yeah, make it a 2.
All right, 2 is good. Okay, and then next one, we'll do minus on the next one. How about that? We'll make that one an x squared. We'll do an x squared term. What do you want the coefficient to be? Just make it even.
6.
6. Okay, and then should we skip the x term?
Yeah.
Just to make it so fun. So the last one, do you want the constant to be positive or negative?
Positive.
Positive.
Plus 15.
15. Okay. All All right, now let's see what happens with this then. All right, so we've created this one ourselves. Again, I'm going to rewrite this though with the 0 terms in there. It's already in descending, by the way, so that's kind of nice. So we got 4x to the power of 5, and then you'd have a positive 0x to the power of 4, and then you'd also have the next one is a positive 2x cubed. I can do better for that's better. Minus 6x squared, and my fraction line isn't long enough. That's a little better. The next term was a 0x that was missing, the x term. And so we put it in there as 0x and then plus 15, right? Kind of long, but it's still doable. And it can be enjoyable. It can't be, unless you're a math nerd. So let's take that. I'm just going to copy it so I don't have to write it twice, even though it's kind of ugly. Just divide it by 2x minus 3. All right, so again, we say, well, how many, the x, I just start with the x's. I got x to the power of 5. I'm going to need 4 more x's to multiply by the x, right? Because x to the power of 4 is x to the power of 5. Sorry, x to the power of 4 times x is x to the power of 5. But then I'd have to take 2 and multiply it by the 2 x's. So that'd be 4. We're going to get rid of that. Kind of a big line there. But now 2x to the power of 4 times the negative 3. Again, that means I would be adding some x to the power of 4s. 6 of them, looks like. So that zeroes out. X to the power of 4, 0 plus 6 would be, well, 6. And then everything else drops. So next up, we got, now I got the 6x to the power of 4. That means I'm going to need 3 of those x's. 6 is positive, so I know this is going to be positive. But I'd have to multiply 2 by 3. So that'd be 3x cubed times 2x, which would be 6x to the power of 4, which is used up, so I'm subtracting that out. Oh, here we go. So 3x to the power of 3 times negative 3 there. Again, it's going to be, we're going to have to add that in as 9x to the power of 3. So that zeroes out. 2x cubed plus 9x cubed, 11x cubed. Yeah, so we get, now it's not a even number. So I kind of meant for them to, but they don't, and that's okay. And so I'm expecting some kind of fractional value to be multiplied here, and that's okay too. So next up, I'd have to multiply just the x's, right? So that'd be, I need 2 more x's there to make this x squared times x would be x cubed. But again, how do you make an 11 from a 2? You have to multiply it by 11 halves. Okay, now the 11's positive, so I know it's going to be plus 11 halves the x's. All right, so 11 halves times 2 is, well, 11. Again, we're taking those away, so that will zero that out. But 11 halves, oh, here we go. 11 halves times the negative 3, that's going to be positive 33 halves x squareds. So, yeah, definitely going to go to my calculator for this one. Yeah, even in this one, negative 6 plus 33 halves, it gives me 10.5 x squared. Which, you know, one button press says it's 21 halves. I'll just make a note of that over here. 10.5 is the same as 11 halves. That should, the reason why I'm keeping it as 11 halves there. 21 halves. Apologies, 21 halves. Is because the fraction may help me with the multiplication. Me, but maybe not you, okay? So that zeroes out. I can drop my 0x's. And then the plus 15 as well. All right, I feel like we're close, but also far away. So, geez, yeah, what are we going to multiply 2 by to get, well, let's start with the x's, okay? So I know I'm going to have to multiply by an x there. X times x is x squared, that's good. But again, what am I going to multiply 2 by to get to 10.5? Well, I would do 10.5 divided by 2 there. And that ends up 5.25, or if you want the fraction, 21 fourths. Now that 10.5 was positive, so I know this is going to be positive. I'm going to put the fraction just because I can fit it in better. But it's the same as 5.25. Okay, so 5.25 times 2 x's there would have given us that 10.5x. Taken away. And then since it's positive, times 3, let's see what I get, times 3. Okay, that's, well, minus now, or plus, because it's being multiplied by the negative. Yeah, the decimal's gonna be better on this one, 15.75 x's. Okay, so that zeroes out the 10.5x squared, but now I got 15.75 x's plus 15. Only one last step here for us, I think. So 15.75, what do I gotta multiply that by 2 by to get that 15.75? I just divided the two numbers, and it tells me that, yeah,
875.
and it's positive, so positive 7.875.
X.
And this would have been 63/8, if you're interested. Now this one I don't need to make that an x, the 7.875, right? Because when I multiply that by 2, it's already got the x, and then that would have been 15.75 x's. Okay, taken away. And then 7.875 times the 3 there. Oh, it's pretty ugly. But we are adding it in any case, 23.625 right there. So, but that's zeroed out. Then I just got to add that to 15. That'll give me my remainder, which, you know, is still pretty ugly. But the remainder here, 38.625. Or if you want the fraction, which I don't know that anyone does, but 300. There we go. All right, let's see if we can write this then as a complete quotient. 2x to the power of 4 plus 3x cubed plus 11 halves x squared. I guess I'm mixing fractions and decimals. Hopefully that's okay. Positive 21/4 x's. And then, you know, I'll put the fraction in here just because it may look prettier. And then finally the remainder of 309/8. Okay, or, like we've seen before, you just write the whole thing out, but then just add it. Add the remainder. Well, I guess I would probably want the decimal here, huh? 38.625 over 2x minus 3. Either one works.